Okay, so hello and good day everyone. Welcome again to Principles of Reinforced Concrete. And for today's meeting, we will just be continuing with our discussion before, which was about the design principles. And as a recap, guys, so I will just be going back here since this should be our first slide. So once again, for our recap, the main design philosophy is that the strength of your structural member or the design strength should be greater than or equal to the strength, the one that is to be being carried. So let's have an example here. So suppose that we would be having a certain, let's say a certain beam. So for example, that this is to be a beam. And your beams are often flexure members. So when we say flexure members, beams are to be subjected with moments. So for example, that we will be having certain moments here. So meaning that this structure right here is to be a flexural member. And in here, guys, so let's say that the moment that is to be imposed in this beam is to be given by mu. So this is just an example once again, everyone. So mu. So in this case, the strength of this member in flexure should be greater than mu. With that, guys, the nominal moment should be greater than should be greater than or equal to mu. So in Tagalog, guys, yung beam natin dapat mas malakas siya kesa sa binubuhat niya. Kasi paano nga niya naman mabubuhat kung hindi siya mas malakas doon sa bubuhatin niya. For example, kung ang capacity niya is let's say 130. So by that, guys, ibig sabihin 130 lang yung kaya niyang buhatin. So above that, so for example that he will be carrying the beam will carry 131. So ibig sabihin din niya na kaya yun. So it would be as simple as that, no? So once again, for our main design philosophy, the strength of your member should be greater than the anticipated magnitude of the load that is to be being carried. So rephrase ko ulit. So the strength of the member should be greater than the anticipated magnitude of the effect of the load that is being carried. So once again, ito, meron nga tayong moment. And let's say na beam nga ulit siya, no? So let's say we would be having another beam right here. And let's say that it is to be simply supported. Teka, i-move natin tong buo. So let's say that this is to be your beam. And let's say that it is to be simply supported. So let's say that that is to be it. And for its shear diagram, by the way, of course, dapat kailan pala natin i-subject to ng load. So let's say that this is to be its load. So it is to be a uniformly distributed load. So let's say that that is to be it. And for its shear diagram, it would be looking like this. So this is to be its shear diagram. And for its moment diagram, it would be looking like this. Oops, sorry. Isa pa. So its moment diagram will now look like this. So approximately it would be yan. So approximate lang yan once again. So meaning that, guys, if this is to be your maximum moment, so this is to be your maximum moment, and this is to be your shear maximum or Vmax, and this is also your Vmax, it means that your member, so this structural member, should be stronger than your Vmax and should also be stronger than your Mmax. So yun lang yung napaka-basic natin na design philosophy with all of our structural engineering subjects, just like your principles of steel design, reinforced concrete design, and if you want to study timber design. So ganun lang naman talaga yung main idea niya or yung main philosophy niya. Okay, and yun pala, guys. So once again, from the previous meeting, we have discussed about the various uncertainties. So once again, there will be various uncertainties in the design of reinforced concrete. Like let's say the uncertainty of the members, the uncertainty of the magnitude of the loads. So with that, guys, so for example, we have, of course, a required strength. So let's say we have anticipated, let's say 80 kilonewton meter. So let's say that we have anticipated this amount of load or this amount of moment. But let's say in actuality, so sa totoong buhay, naging 84 kilonewton meters yan. Though it is not that much, so it just increased by 4 kilonewton meter, but if you have designed your member to withstand just this, it means kapag ito na yung load natin, if this is to be your load, your member will now fail. So there. So that is one uncertainty. So, and that is to be the uncertainty in the load. And another uncertainty is that maybe during the construction of your reinforced concrete, there will be imperfections in the construction procedure that will reduce the strength of the members. So with that, guys, so for example, that the design strength is, let's say, 155 kilonewton meters. So this is just for your design strength. But when you were constructing it, so nagkaroon kayo ng onting imperfection, no, sa pag-construct ng building. So let's say that the actual strength of it was reduced to 130 kilonewton meter. So this is just for pretend. So once again, we would be having various uncertainties. And for us to address those uncertainty, we will now be applying factors of safety. So maglalagay tayo ng factors of safety natin para ma-address natin yung issue ngayon ng uncertainty. So for your required strength, guys, we will now be applying factors in our load combinations. So once again, our load combination will be as follows. So these are to be our load combination. So confirmation, everyone. Are these factors readable? So 1.4D, nababasa ba siya? 1.2D plus 1.6L, nababasa ba siya? So are these readable, guys?
Yes.
Yes, sir.
Okay, so very good. So once again, for us to address the issue on the required strength, we will be increasing the loads itself. So yun, if your primary load is to be a dead load, so you will be increasing this, so 1.4 dead load. Then if you would be having your wind loads and let's say your earthquake loads, they are to be as follows. So ayun, guys, and the thing here is that if you have all of these loads, what you will be doing is that you will be solving for all of them. So you will be solving for all of them. Then after solving for all of them, you will now be choosing the largest magnitude or the biggest load. And yung pinakamalaking load, so the biggest load is to be the one that is to be critical. So kapag ganon, yung pinakamalaking load, so the biggest load is to be our basis for our design. So that is for our required strength. So once again, that is to be our, let's say, our way on that is to be a way on how we would be addressing the uncertainty of the required strength. But how about for the design strength? So ayon, for us to address the design strength, we will be reducing the strength of the material itself. So for example, 150 kilonewton meter yung mismong strength nung ating structural member. Ang gagawin natin is i-reduce natin siya kunwari. So i-reduce natin siya, let's say, up until 135 kilonewton meters para kapag ito yung dinesign natin, then siguro medyo lumagpas itong required strength natin ng 136. If ito yung ginamit natin, yung in actuality, ito naman yung magiging strength niya, in actuality. Pero ayun nga, i-reduce na lang natin siya para mas safe tayo. So ayun. And with that, guys, if we are to reduce our design strength, we will now be multiplying it by our reduction factor. And our reduction factor is to be given by the it will be given by the symbol phi. So there, and your symbol phi is to be given by the following. So it can either be this one right here if you are to be designing it in moment or axial force or combined moment and axial. So that will range from 0.65 up until 0.9. And if you are to be designing it in shear, you will be using the reduction factor of 75% or 0.75 and others. So with that, guys, if you are to be designing a flexural member, kapag moment siya, no, your you call that, your equation will now be equal to, so phi, so this is to be the reduction factor times the nominal strength of your member. So when we say nominal, this is to be the true computed value of the strength of, well, your material. And this should be greater than or equal to whatever your load combination, whatever load combination you will be computed. You will be computing, I should say. I'm sorry. So with that, guys, this is now to be M times U. So ito U tong mga to, no? So this is basically your ultimate moment. Okay, so now, the question is, for the required strength, paano ba natin malaman itong required strength na to? So, ayun, so that is to be our main concern for today's meeting, no? So, ayun guys, for the magnitude of the required strength, we can solve for this. So, we can solve for this using any method from theory of structures or from statics of rigid bodies. So for example, guys, that we will be having a certain frame. So when we say frame, it would be this. So maaring ito. So siguro ito yung frame natin. So once again, guys, this is just an example. So let's say that we have a certain frame. Or let's say we have a certain simply supported beam. Or maybe a continuous beam. So once again, this is just an example. So by that, maybe this one right here is to be fixed. Then let's say we have a pin support here. And let's say we have a roller support here. And we have another roller support here. So this is just an example, guys. So if we have these structures right here, we can solve for its moment, shear and moment diagram for us to get its maximum value by using any of the following. So we can use moment distribution. So you should also, you should already be familiar with this. So moment distribution method, or maybe you can use slope deflection method, or maybe you want to use let's say matrices. So matrix, so pare-parehas lang yung mga yan. Pare-parehas lang yung kalalabasan ng yan. And of course, for this, for your simply supported beam, since this is to be determinate, you can solve for its maximum shear and maximum moment using statics of rigid bodies, wherein you would just be solving for the reaction, then drawing its shear moment diagram. So once again, if you would be having an indeterminate structure like your frame right here, or let's say this continuous beam right here, you will be using moment distribution, slope deflection, or matrix. And well, it is not to be limited with, in those procedures. So kung meron pa kayong alam na ibang procedure, pwede din yon. Okay, so if you are wondering, guys, is there a way for us to solve for the required strength in this part? So once again, is there a way for us to determine the required strength right here without going so much trouble? So in Tagalog, maari ba nating masolve ang required strength dito nang hindi tayo nagmo-moment distribution, nag-slope deflection, or nag-B-matrix? So wala. Hindi pwede yun. So dyan po nagtatapos ang ating debiro lang. So the short answer to that in reinforced concrete is yes, we can solve for the required strength, even though that we can, we won't go through in these methods if we would be following this, if these conditions are satisfied. So once again, guys, so ito, so from NSCP, so NSCP 406.5, we have a simplified method of analysis for non-prestressed continuous beams and one-way slabs. So we can actually use this method for us to determine the required strength if, once again, all of these ones right here are satisfied. So first na condition, is that your members should be prismatic. So what does that mean? So punta tayo dito. So once again, these are to be the conditions, no? So it is said here that the members should be prismatic or members are prismatic. So what that means is that for a certain structural member, its cross-section in one end should be its cross-section throughout. So for example, we have a certain beam. So let's say that this is to be your beam. And let's say the cross-section at this part is to be a rectangular one, and let's say that it is to be 250 by 400, just for pretend. And this section should be constant throughout. So sa lahat ng sections na to, dapat 250 by 400 siya. So that is what we mean by prismatic. And if your structure would look like this, so for example, this is to be once again your beam. So we have a section here and it increases. So medyo mas lumaki siya, no? So let's say that at this part, the section is to be once again 250 by 400. And let's say at this section right here, let's say that this is now to be 300 by, let's say, 700. So it is in this case that it is not prismatic any longer. So with such, hindi natin pwedeng gamitin yung simplified method. So delete ko lang ulit to. And yun guys, so for the second condition is that the loads should be uniformly distributed. So if this is once again to be your beam, so your loads should be uniformly distributed. So ito siya, dapat. So ayan yung uniform distribution natin. So you are already accustomed with this, guys. So yan. So what if there is to be a certain point load here? Or let's say that we would be having a certain trapezoidal load here. So if we would be having these two right here, or any of these two, it means that we cannot use this method any longer. So once again, the main requirement of it is that the loads should be uniformly distributed. Okay, so anyway, so proceeding guys, so the next condition is that your live load should be less than or equal to 3 times your dead load. So self-explanatory. So yung live load natin dapat mas malaki, mas maliit siya or kapantay niya yung 3 times ng dead load. So that is another condition. And another condition is that it should be having at least 2 spans. Kasi kapag 1 span siya, like this one right here, ba't nawala? Kasi kapag 1 span siya, bakit kapag gagamit ng simplified? Hindi mag-shear moment diagram ka na lang, no? Ng basic, ng statics. So ayun, so it should have at least 2 spans. So 2 or more, pwede yun. Pwedeng gamitin itong simplified method natin. And another thing here, so the last parameter or the last condition that we must satisfy is that the longer of the 2 adjacent span does not exceed the shorter by more than 20%. So I will be drawing once again. So for a while. Okay, so let's draw once again. So suppose that this is to be your beam. And let's say that this is to be your support here. And let's say that this is to be your support here. So as you can see, we have 3 spans. So span number 1, span number 2, and span number 3. So it is said here that if this is to be your length number 1, this is to be your length number 2, and this is to be your length number 3, it means that, for example, that your length number 1 and length number 2, if you would be comparing them, so let's say that your L1 is shorter, dapat daw hindi mas maiksi yung L1 natin ng 20% sa L2 and the other way around. So ganun din sa L2 and L3. So dapat hindi nagkakalayo yung dimensions nila, yung length nila ng 20%. Pero walang kinalaman yung L1 sa L3. So wala namang kinalaman yan. So yung magkakatabi lang. So those are to be the conditions that must be met if we are to use this simplified method. So ayun guys, so the usage of the simplified method is, well, quite simple. Thus, simplified, so no pun intended. Talagang simple lang yung paggamit nito. And in us using this method, napakasimple lang, to the point na gagamit lang tayo ng formulas. So direct substitution lang. So this is this is very easy as long as you understand these conditions right here. So we have our location and we have our condition. So I will be explaining this to you right now. But first, can I get a confirmation? Are these readable? Nakibabasa ba yung mga formulas natin, guys? So these are to be our formulas.
Yes, sir.
Okay, very good. Okay, so ayun, if you want to get the positive moment here, so this is to be the formula, whereas your W is to be your uniformly distributed load, so uniform load, and your ln is to be this one, or the length, or the average length of whatsoever. So I will be explaining that in detail to you later. But first things first, I will be explaining the location and the condition first. So explain ko muna kung anong mga ibig sabihin ng tag-iisa dito para kapag kayo na yung magsisolve, for example, in your laboratory subject, alam nyo na kung paano. Okay, so let's say that we would be having this setup. So I have pre-drawn already para di na tayo matagalan. So this one is to be your column. So the vertical members are to be your columns, I should say, kasi nga plural. And your horizontal members here are to be your beams. So, guys, can you imagine it? So, columns and beams. Confirmation. Naintindihan nyo yung setup natin? Guys, do you understand? Okay, very good. How about for the others? Do you understand our setup here?
Yes, sir.
Okay, how about for the others?
Yes po.
Yes, sir.
Okay, sige. So, ayan. So, once again, this is to be our setup. So, as you can see, guys, we have 3 spans. So, this is to be span number 1, span number 2, 3, and 4. And we have our exterior and interior span. So, when we say exterior span, so self-explanatory, those are to be the span that are exterior o yung nasa labas. So, with such, this is to be our exterior span number 1, and this is to be our exterior span number 2, or kahit ito yung 1 mo or ito yung 2 mo, basta yung dalawa na yan yung exterior span. So with such, meaning that these are to be your interior span. So interior. So there. Okay, so let's fill this up first. So of course, guys, that if you would be drawing, if you would be drawing its moment diagrams, it would look like this. So this is not this is not drawn into scale. So approximate lang to, guys. Oops, sorry. So ito. Hirap naman mag-drawing. So ito. So this is to be its approximate moment diagram, as well as for this, as well as for this, as well as for this. So guys, once again, these are to be the approximate moment diagrams. Okay, so going back here, so for the positive moments, so ito yung mga positive moments natin, guys. So it would be at the top. So ito yung mga positive moments natin. Okay, so it is said here that for the end span, the positive moment would be this one or this one. So paano ba tayo mamimili? So itong una daw, this indicates that the discontinuous end is to be integral with support. And this one right here states that the discontinuous end is to be unrestrained. And as you can see in our subject here, in our example here, yung dalawang discontinuous end natin, by the way, guys, this is to be your discontinuous end kasi hindi na nga siya nag-continue. And these are to be your continuous. So once again, the one on your left, leftmost, that is to be your discontinuous. And the one on your rightmost, that is also your discontinuous kasi nga hindi na siya nag-continue. And it is also said here that, teka, mas maganda ata i-copy-paste ko. So I will just be copying this here. So okay, so I will be decreasing its size. Guys, can I get a confirmation if it is to be this small? Nababasa pa ba? Ito hindi na.
Hindi na, sir.
Hindi na. Okay, sige. Wag na lang natin isama yan para di tayo malito. Anyway, so once again, if this is to be its condition, so sabi dito, discontinuous and integral with support. So as you can see guys, yung discontinuous end natin has its support. So it is to be integrated. So meaning that the positive moment at that span is to be W ln squared over 14. So guys, ito keyword. Key fraction. Teka, nasa yung pen? So ang positive moment dito is 1 over 14. So ganun din sa kabila. 1 over 14. It is because that it satisfies this condition. However, if it would satisfy this, so sabi dito, discontinuous and unrestrained. So what that means is that, for example, wala kang column dito. So for example, ganyan lang yung setup natin, and its moment diagram would now look like this. So magiging ganito yung moment diagram niya, no? Straight line pala to. So ito yung moment diagram niya. The positive moment here is to be W ln squared over 11. So, ang fraction niya is 1 over 11 or yung coefficient niya. But once again, since our structure is to be restrained in both ends, teka, di ko ma-delete. So once again, our structure is to be restrained in both ends, thus 1 over 14. Kaya 1 over 14 yun nandito. Okay, so moving forward guys. So it is said here that for the interior spans, the positive moment is to be WLN squared divided by 16. So with such, this is now to be 1 over 16 and 1 over 16. Since both of these are, let's say, your interior span. So interior span kasi itong dalawang to, so meaning 1 over 16 yung positive moments nila. Okay, so we are already done with the positive moments. But how about for our negative moments right here at the bottom part? Okay, so here, so for our negative moments, guys, so let's go from cell to cell. So for the first location, interior face of exterior support. So with that guys, what is to be the exterior support? So looking at this, so ano ba yung support dyan na nasa pinakalabas? So it would be this. And it would also be this. So both of them are to be your exterior supports. So sabi dito, for the interior face of exterior support, it would be this one or this one. So for the interior face, meaning that it is to be this one. So ito yung face kasi. Yan yung interior face ng exterior support. And ito din yung interior face ng exterior support na pangalawa. Okay, so for the moment, once again, that may be this one or this one. So for the first one, sabi dito, member built integrally with supporting spandrel beam. And this one right here is to be for your members built integrally with supporting column. Okay, so ang sabi dito, supporting column. And as you can see, our support here are column. So ito, column siya. And this one right here, it is also to be a column. So with such, we would be using 1 over 16. So guys, nakikita ba tong fraction na to, over 16? Is it readable, Miss Trinidad?
Sir, hindi.
So this one right here kasi, 16 nakalagay dito. Teka. So blakihan natin, no? Okay, so I would just be increasing this. So by the way, guys, this table right here is to be in page 4-38 of your NSCPs. So I will just be increasing this for a moment. So para mas kita. How about, oops, sorry. How about now, guys? Is it now readable?
Yes, sir.
So eto, nandito kasi tayo kanina, guys. So member built integrally with supporting column. And as you can see, yung supports natin are columns. So thus, we will be using 1 over 16. So ito. So, teka, nasa na naman yun? So ito, 1 oops, gawin ko na lang green para mas ma-differentiate. So, yellow pala. 1 over 16 and 1 over 16. So, these are to be for the exterior face, the interior face of the exterior support, which is to be this. Okay, next, going from cell to cell once again. How about for the exterior face of first interior support? So our interior supports would be this one, and this one. So self-explanatory when we say interior support, those would be the support that are interior. Paano ba ibang sabihin? Basta yung nasa loob. And according to this, exterior face of first interior supports, so the first interior supports are to be this one and this one. So mga manggagaling sa labas papunta sa loob, yun yung ating mga first interior support. So from that, if we have two spans, we will be using 1 over 9, so 9 ito. But if we have more than two spans, we will be using 1 over 10, so divided by 10. And as you can see in our example, we have 4 spans, so 1, 2, 3, and 4. With such, guys, we will now be using 1 over 10. Okay, so writing them here, this is now to be 1 over 10. So once again, guys, exterior face pala to, no? So if this is to be your first interior column, this is to be your interior face, and this side is to be your exterior face. And if this is to be your first interior column, once again, the one on your right, this face is to be your exterior face, and this face is to be your interior face. Self-explanatory. Interior, loob, exterior, labas. Okay, so once again, with such, this is to be 1 over 10. So these are to be the coefficients, no? Okay, so next, ito pa. So for the face of all other supports, erase natin. Okay. So for the face of all other supports, those are to be WLN squared over 11, thus 1 over 11. So with such, guys, this is now to be equal to 1 over 11. So 1 over 11, 1 over 11, and 1 over 11. And as you can see, we already have completed our coefficients. So ngayon, paano ba tayo magsasolve? So once again, we need the values of our W and our LN. So palitin ko lang ulit. So ito nga kasi yung general formula, no? So WU times LN squared divided by these coefficients. So for example, you would be solving for the positive moment here divided by 14 and etc. Pero ano ba yung WU? So your WU is to be your uniformly distributed load once again. So kunwari ang gusto mong isolve is WD, so yung yung uniformly distributed load ng dead load. Kung WL, uniformly distributed load ng live load. Kung roof live load, WRL, and etc. But if you want to solve for the, nasan ba yun? If you want to solve for this one directly, kung yung factored moment na agad factored load na agad yung gagamitin mo, WU yung gagamitin mo. So, WU. So, okay. Anyway, so those are to be for your factored moments. And as for your LN, so for your LN once again, so for your LN, according to this bottom part, teka, lakihan ulit natin para mabasa nyo. Okay, so for your bottom part, though hindi sinabi dito, but for your positive moments, kasi ang sabi dito, to calculate negative moments, LN shall be the average of the linear clear span lengths. Pero sa positive moment, though hindi naka-indicate dito, explain ko na lang, that if you are to solve for the positive moments here, the ln that we will be using are to be the span length. So, ganun lang kasimple. So, teka, dito. So, ln 1, ln 2, ln 3, and ln 4. So, for example, that you are solving for the positive moment here. So, m max na positive, for example. This is now to be equal to, so 1 over 14 dito. So, W times ln 4, since this is to be its span, squared divided by 14. So, direct substitution, kung ano yung may solve nyo dyan, that is to be your M max or MU already. So, MU. So that is to be your MU already, and this is to be the required strength of your structure already. So yan. And if you would be solving for ln3 or this one right here, you would be using this ln. So kung nasa anong span siya, yun yung gagamitin mo. So with such, eto ln3 na siya. So ln3 na yan dyan. Okay, but ayun na, ganun lang kasimple yung sa positive moment. So, can I get a confirmation for the positive moment? Do you understand this one right here, guys? Guys, confirmation. Did you understand this equation? Okay, so take it in. Florencio, understood?
Yes, sir.
Okay, very good. Miss Trinidad, understood?
Yes, sir.
Okay, very good. Miss Baklili, understood?
Understood, sir.
Miss Wansi, understood? Mukhang wala si Miss Wansi. Mr. Banaag, understood?
Yes, sir.
Okay, very good. So, ayan, direct substitution. So, those are for your positive moments. But what about for your negative moments? So, for your negative moments, the value of your ln actually have a catch. So, yung ln natin, it does not necessarily mean na kapag etong negative moment na to, pag etong negative moment na to yung yung isa-solve natin, hindi agad ito yung gagamitin natin. So, for the ln that we will be using, it should be the average of the two adjacent lengths. So, if this is to be the moment that you are solving, you will be getting the average of both of this. So, yung average nila, so ln1 plus ln2 divided by 2, yun yung gagamitin mo para dito. However, for your exterior faces, so in this part right here, so wala naman siyang katabi, no? So, meaning, ito na yung gagamitin mo. And the one on your right, if this is to be the moment that you will be solving, ito na din lang yung length mo kasi wala naman siyang katabi. However, if you would be solving for the other faces like this one, so for example, ito yung isosolve mo guys, nasa gitna yung 1 over 11. The ln that you will be using is to be the average of this and this. So kung ano yung magkatabi. And if you are solving for this, the ln that you will be using is to be the average of both of this. Or, of course, the adjacent lengths, yung adjacent sides nila. So, let's say that we will be solving for the negative moment at this part. So, ang dami kong bilog para mas ma-emphasize. So, our MU is now to be equal to our uniformly distributed load times the average of these two. So, ln3, So, ln3 plus ln4 divided by 2. So, ito, formula, squared divided by the coefficient. And 1 over 11 yung nailista natin dito. Thus, 11. So, this is to be our formula. And this should be given, all of this should be given. Yung W, dapat alam niyo yan. ln3 pati ln4, given yan sa problem. So guys, understood on the negative moments?
Yes, sir.
Okay, very good.
Yes, sir.
Okay, so ayun lang. Kapag positive moment guys, napakasimple. kung ito yung positive moment na ito yung solve mo, ito lang yung ln niya. So kapag ito yung positive moment na solve mo, ito lang yung ln niya. And if we would be solving for the negative moments, we will be having a catch kasi hindi na ganun kasimple. For example, you would be solving for this. Ang ln na gagamitin mo is to be the average ng ng magkatabing lengths. And since nandito siya sa side na to, sa posting ito, you will be getting the average of this and this. Thus, if we would be reading this table once again, to calculate negative moments, ln shall be the average of that adjacent clear span lengths. So, ayun. And guys, take note, clear span ha. So, for example, no, meron tayong column ulit, column ulit, column ulit, and column ulit. And let's say that this is to be your beam. This is to be your beam. And let's say the given dimension here is, let's say, at this part, center to center, kunwari. So, kunwari yun yung given. So, for example, 5 meters. Then, let's say 4 meters dito. And let's say the column's dimension is to be 400 by 400 mm. So with such, that is to be 0.4 meters by 0.4 meters. So yung length dapat natin, guys, is to be the clear span length, and it should be this one only. So ito kasi center to center, pero ito lang dapat yung kinoconsider natin sa mga beams natin. And those are to be the clear span. And with such, if the half of this column is to be 0.2, and the half of this column is to be 0.2, kasi nga 0.4 yung kalabasan niya. So, looking at the calculator to your left, so 5 meters minus 0.2 minus 0.2, kasi nga dalawang side, that is to be 4.6. So, thus, this is to be 4.6 meters. And as for this one, so 4 meters minus half of this column, which is 0.2, minus half of this column, which is 0.2. Thus, so 4 minus 0.2 minus 0.2, that is now to be 3.6 meters. So guys, understood? Clear span dapat, hindi center to center spacing. Understood, guys?
Yes, sir.
Okay, very good. Okay, so once again, that is to be for your ln. So ln and for your moment. But what about for your W? So how can you solve for the uniformly distributed load? Because if you would be looking at your NSCPs, or the National Structural Codes of the Philippines, the loads there are to be given in kilopascal. So naka-kilopascal kasi yung mga loads na nandun. So kilopascal. And this is to be a pressure. And kilopascal is to be kilonewtons per square meter. So ito yung load ng pressure natin na nasa NSCP. But for your W, that should be kilonewtons per meter. So as you can see, there is to be an inconsistency in units. So this is to be in terms of area, and this is to be in terms of linear measurement, which is in meters. So paano ba natin maiko-convert itong kilopascal natin para magamit natin as W dito sa equation na ito? So sa mga equations na nandito. Okay, so if this is to be your floor plan, yung structural plan. So guys, top view to, no? So plan view. So the one that is drawn in yellow. So yan yung mga beams natin. And the ones that are drawn in red, those are to be your columns. So can you guys visualize beams and columns? So,
Yes, sir.
yan, very good. So, nasa tuktok kayo, tinitignan niyo siya pababa. Thus, the yellow lines are to be your beams, and yung red natin are to be your columns. Okay. So, for us to convert your uniformly distributed load, your pressure load into uniformly distributed linear load, what we will be doing is that we will be multiplying it by tributary width. So, ano ba yung tributary width natin? So, your tributary width is to be length times, area divided by length, pero tsaka na yun. So, when we say tributary kasi guys, yun yung binubuhat ng member mo. So, for example, in these columns right here, so mamarkan ko ng blue, I mean beam pala. Ito, may beam tayo dito, then may beam tayo dyan. When we say that this is to be its tributary area, so for example, maglalagay lang ako ng imaginary line dito, imaginary line rin dito, if that is to be the area. So let's say that this is to be its tributary area. So once again, tributary area. So if that is to be the tributary area, it means that that area is to be carried by your beam at the middle. So ito. So ibig sabihin itong beam natin na nasa gitnang ito, binubuhat niya lahat ng nakapatong dito. And your tributary area, its dimension, so this is to be its tributary width. Ito pala. Ito yung tributary width natin, yung buong yan. And for us to get its tributary width, that is basically half of the length here and half of the length here. So, ganun siya, no? Teka, paano ba tayo magbibigay ng example? So, ayun guys. So, ang assumption dyan is for, if you have your beams here, bubuhatin niya yung kalahati sa taas, yung kalahati dito, and bubuhatin din niya yung kalahati dito if this is to be a one-way slab. So, one-way interaction. So, kalahati. So, what about for the tributary area of this particular beam at the top? So, paano dito? Itong beam na nasa taas, yung sinishade ko ng puti. So, anong tributary area niya? So, its tributary area is just to be half of this length. So, kalahati dito. Tapos, kalahati din dyan. So, meaning, yung tributary area niya is to be this. So, ito yung tributary area ng nasa taas. So, parang kalahati lang kasi wala naman siyang binubuhat sa part na to. So, if let's say the whole of this is to be L. So, let's say that this is to be your L. So, yung tributary width niya is to be L over 2. So, this is to be its tributary width. And ayun, for us to convert our pressure into a uniformly distributed load, we will just be multiplying this. We will just be multiplying this by our tributary width. And yung tributary width natin is to be in meters. So with such, magka-cancel out yung meters, magiging kilonewton per meter na siya. Okay, so we will be having an example next meeting. And ayun, so we will be having an example next meeting for you to understand it better. So eto siya guys. Pero we have a catch once again. So eto kasi guys, one-way slab. One way. So kung naalala niyo yung lesson natin before, kapag one-way kasi, so suppose that this is to be your beams. So beams yan na palibot. When we say one-way slab, the distribution of loads is to be in one way only. So, ito yung kunwaring load natin, no? I mean, tawag dito. Guys, plan view pa rin to. So, kunwari may load dito sa slab na to, sa area na to, yung distribution niya, pupunta lang siya sa dalawang sides na to if it is to be a one-way slab. Pero pag two-way slab, magtutulungan lahat ng beam. So, may iba pupunta dyan sa taas. So, iba pupunta dyan sa taas. Iba pupunta sa baba. Iba pupunta sa left. Iba pupunta sa right. And whatsoever. So this is for your two-way slab. So once again, for your one-way slab, isang side lang siya. Papunta lang siya sa direction ng short direction. So it would be this. So kapag ganito yung distribution natin, one-way lang siya. So, if this is to be the setup, parang i-assume mong walang tulong itong dalawang beams na nandito. So, parang ganun yung assumption natin dito, no? So, yung mga loads natin, pupunta lang siya dito sa, dito sa beams na to. So, looking at the laser pointer, medyo malabo na kasi ang dami ng kasulat. Pupunta lang siya dito, 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 and dito. So, we are assuming na walang tulong itong mga beams na naka-vertical sa point of view natin. So, kumbaga parang hindi sila nakakatulong. So, yun yung assumption. So, okay, to wrap things up, guys, when we say tributary area, so, gawa ulit tayo ng beam dito. Kasi medyo malabo na yung kanina. Then, meron na naman tayong beam dito. Then, meron na naman tayong beam dito. Guys, plan view na naman to. When we see tributary area, it is to be the area that your structure is to be carrying. Or yun yung area of responsibility niya. So, kung etong beam na to, ang tributary area niya is ito. Kunwari yan yung tributary area niya. It means that that beam will carry every load that is to be located at that area. So, kunwari, dyan ka nakaapak, i-assume mo na yung beam na to yung nagbubuhat sa'yo at hindi ito. So, that is to be it. And for your tributary area, that is basically your length times your tributary width. So, for your tributary width, that is to be given by this. So, punta tayo sa left. So, ito yung gitna, no? Just get its length. I mean, half of the length here. So, let's pretend that this is to be L1. Kunwari, L1 yung buong yan. Then, let's say L2 itong buong to. L1 pala sabi ko. L1 yung nasa taas and L2 itong nasa baba. Yung spacing nila actually. So, this is to be L1 divided by 2. And this is to be L2 divided by 2. Or yung kalahati lang ng span. So, did you guys understood? Naintindihan ba yun? Or hindi? Mr. Ebreo, understood or hindi?
Yes, sir.
Okay, very good. How about for Anthea? Did you understand? Did you understand?
Yes, sir.
Okay, very good. For Carl, Eliezer, naintindihan ito? Carl, are you there? Wala? Okay, so mukhang wala. How about for Joanna?
Yes po.
So, naintindihan mo yung idea natin ng tributary area? Joanna?
Yes po. Sir.
Okay, very good. Chandni, did you understand our lesson for today?
Yes, sir.
Okay, so very good, no? Okay, so before I end our meeting for today, guys, are there any questions about anything that was discussed today? Okay, so countdown ako. So 5. Okay, Mr. Choi.
Sir, yung sa pag-determine kung one-way slab or two-way slab po yung gagamitin, ano na po yung parang magde-determine kung
Okay.
alin yung gagamitin?
Sige, balik tayo dito. So let's go back here. So delete ko muna to. So for example, you still don't know if this is to be a two-way slab or one-way slab. And this slab has its own dimension. So we have its length. Hindi, ganito na lang. So, sige, length and width. So, meron siyang dimensions na dalawa. So, now you will be getting the ratio of it. So, yung mas maliit na side divided by yung mas malaking side. So, W over L. So, kunin mo yung answer niyan. And compare if it is to be less than or equal to 0.5. And ayun, and kapag ganito yung answer, kapag greater than or, less than or equal to 0.5, ito, one-way slab. So, one-way slab. Yan. And if hindi, if it is to be greater than, two-way slab na siya. Kapag W over L is to be greater than 0.5. So, two-way slab na siya. So, yan. So, for example, meron tayong tingin kayo sa calculator natin, guys, no? For example, we have a slab. Yung W niya is to be 5 meters. So, 5 meters. Then, yung isang side is, let's say, to be 7 meters. So, 5 over 7. So, equal sign. Ang answer natin dito, 0.71. And since it is to be greater than 0.5, two-way slab siya. So, two-way slab. But, let's say, if we are to have a certain width of 5 meters, then, for example, yung length niya is to be 17 meters. Hindi, wag masyado malaki. 12 meters, for example. So, 5 over 12, kapag ganyan, check mo yung answer. So, it is to be 0.416. So with such, it is to be less than 0.5. So one-way slab kapag ganito. So yun. Mr. Choi, did you understand?
Yes, sir. Thank you po.
Okay, how about for the others? Naintindihan nyo kung ano yung one-way pati two-way?
Yes, sir.
Okay, very good. So, questions? Wala? So, okay. So, if there are no more... Okay, Nash. What's your question? Mr. Banaag? Or napindot? Or nagta-type? Okay, so I will be waiting for 5 seconds. So, 5, 4, 3, 2, 1. Okay, mukhang wala naman atang tanong si Mr. Banaag. So anyway, if there are no more questions, I will now be ending the recording. And if you have questions, you can still message me. So wait lang, don't leave.